Good afternoon, everyone, and welcome to live stream mic build number 6. It's been a while since number 5. We've been super busy, so but I do hope to do more of these. So please let me know if they're helpful or what you want to see. Today we're going to be building the 990 XF circuit kit, which is a brand new product, and so. As we're moving forward, please let me know if you can hear me, if you can see, or maybe better if you can't. So yeah, thanks to those of you who have already joined. So the only agenda item to announce is that I will be giving away one of these kits to one of you, hopefully. And the way it's going to work is everyone who leaves a comment on the video will be an entry into the drawing. Now you can't, I believe YouTube will not let you leave a comment until after the stream is done. So I don't mean the chat that's running right now. I mean a comment on the video. So after it's done, after the stream's done, or come back tonight or tomorrow morning, throw a comment up there and I will pick a winner based on one of those comments. All right. So we're going to start with disassembling the microphone. Jacob, thanks for confirming. So this is a genuine eBay refugee MXL 990 in surprisingly good shape. Just a little dent here. So we're going to start by doing something we've never done on camera, not because it's super challenging, but really just so that people who join late won't have missed anything too critical. We're going to take this apart. So I've seen people have this issue. This won't unscrew if this thing is on. This is part of the swivel mount attachment. So if this is on your mic, you have to take that off first. And then this unscrews and can be set aside, and the same with the trim ring. Those can just be out of the way. So this is the microphone here. The next thing you need is a small screwdriver. So these screws hold the whole thing together all at once. It makes it a little awkward to reassemble. So you just have to spin these two screws out, and then you want to be careful to hold on to these standoffs because you will need them later. Okay, and hang on to this too. This makes a very useful stand for later when we're soldering wires. So hang on to that. Put these somewhere safe. Okay. So we're just going to clip these wires because we don't really plan to use this capsule. You could desolder them if you want. So that's one, that's two. And then with the XLRs, you could desolder them. You don't want to cut them too short. I'm not going to desolder them because clipping is faster, and I would want to strip these down to bare metal anyway, but I will clip them right next to the board. So I'm retaining as much length as I can. There we go. So now for the capsule. It's held in place by a couple of screws here. So you just have to loosen these two screws that hold the capsule in its harness. I always thought it was kind of funny that this capsule, I've seen it described as a large diaphragm. It's not. It's actually identical. If you take this brass housing off, it's identical to MXL's small diaphragm capsules. In fact, they're even threaded. I don't know if the camera will grab that focus, but it is a MXL 603S capsule with this eyelet attached to the terminal there. Okay, next thing is to take off this harness here. You need a flat blade screwdriver. Okay, and you will retain this screw. You want to hang on to that. Now, how do you know front from back? This comes up a lot. So usually, by convention, XLR pin 3 is the rear of the mic. And I don't know why that is. I guess because then the button for the cable's in the front. So when you go to unplug it, it works the same way that your thumb goes. At least that always made sense to me. Check out some comments here. Thank you for the feedback. Looking good. That focus was lightning quick. Well, that this is the slowest focusing camera I've ever owned. Anyway, that's the rear of the mic. And why is that relevant? Well, because when we install the new capsule, which we're going to do right now, you want to know where the front is. Oops. So this is the new, what we're calling the RK47C, and sort of a minimal accessory situation here, because that's all that this particular mic needs. So we're bundling our super saddle and the 2 screws that you need, and this screw is retained from what we just removed. Now, I always recommend using something like this when you install a saddle. And the reason for that is, over time, these things can work their way loose, and it's just a bummer to have to fix. Now, most people watching this ship fewer microphones than probably I do. So it may not ever be a concern for you. But if your mics move around a lot, it's a good idea to put a drop of thread locker in there. So then, and this doesn't necessarily have a front or back. I'm actually going to arrange this. Well, you can actually see it there. So the this has a centered hole and then a not centered, meaning front to back of the saddle. I'm going to put those outer holes towards the front, although it doesn't really matter. Okay, so then you want to make sure that this is lined up with those side rails. Sometimes these rubber inserts can be twisted a little bit. Okay, and then if you did use some thread locker, it's nice to come back in here in case you got too much on there, just because that stuff is kind of gooey and makes a mess, so you can just swab it off. Now for the capsule. Okay. Okay, so this is the new RK47C. It is a single side, true K47. See that single back plate, 34 millimeter, just like in the old days. We are pre-installing the termination wire, this blue wire on the back plate. That just makes this easier to install. So then we line this up. So this capsule will line up with these. Well, here's me doing it backwards. So front of mic, front of capsule, right? The side with the gold on it is the front. So let's make sure that the capsule's pointing the right direction. Now this is the only kind of tricky thing, is you want to look through. I'm sighting through this hole right in the center of the screen there, to try to line up with that the tapped hole in the backplate. And what I've forgotten to put on my bench here is a pair of tweezers. So honestly, let me try this a different way. These small screws and big fingers are a bad combination. I do recommend getting tweezers. Let's try it this way. Okay, and then a small screwdriver. Jeez. It's one of those things that it's easier when no one's watching. There we go. Now, when you're doing this, when you're installing a capsule, don't put that first screw in all the way, okay? Let it catch a couple of threads and then move on to the second. And that buys you some flexibility in terms of this spacing, because sometimes the holes don't exactly line up, and they will line up once you tighten the screws down. But you have to give them a chance. Yeah, there we go. That was easier. So what I'm doing here is kind of gripping the capsule. And of course, you don't want to touch the diaphragm, and you don't want to touch that diaphragm either. So I'm supporting the capsule, but I'm also clamping the weight of the mic in place. This can be easier if you take your dump bucket and rest the weight of the mic on it. Okay, so we tighten that one down. And then this one. Now I said earlier that I'd arrange the supersaddle so that the offset holes are towards the front of the mic. And the reason is that this capsule that way sits a little bit forward. It doesn't really matter, but I like to do it this way. Then we route the wires through the holes in the pedestal. Oops. So I know that the diaphragm wire is white and the backplate wire is blue on this capsule. If you have a short memory span, you can take a Sharpie and you know, front diaphragm FD and then backplate BP, that sort of thing. Yeah, so that is a capsule installation. Now I'm going to throw a grill on there real quick just to keep this clean, and then I'll set this out of the way. And you know, the other thing I should have grabbed, yeah. So I'll just set this out of the way as is, just leaving the grill standing on there as a sort of dust cover. And try to find a place where it's not going to get knocked down. Okay, that was step one. Any questions? Let's see. Bill asks, any preference as to the blue or red version of Loctite? That's a good question. Not really. I mean, I think this one, which is the 242, it says removable, and that's okay. I just want this stuff to be giving me enough adhesion that standard recording studio vibrations won't let the thing work its way loose. I don't need it to be like super glued in there. And I don't really want that either because, you know, if the saddle breaks, which can happen if the mic drops and that super saddle snaps in two, I would rather be able to remove the screw if I needed to. And with this stuff, I can. So this is enough adhesion for me. It's a good question. Right on. Okay, so let's talk about the kit. So this is a new transformer coupled kit, and we've done some cool things with it. Try to make it easy to build. Try to make it low cost. Some other nice stuff too, like this circuit board. We're having these machined all the way around at the fab, so you don't have to sand off the mouse bites, you know, the perforated edges when you punch it out of a panel. So it's kind of already pretty finished that way. Now what I've done in advance to try to expedite this, because I'm naively hoping to finish this mic today. I honestly don't have a great track record with knocking one of these out in one session. And I do try to keep these to an hour because otherwise it just kind of goes on forever. I've pre-bent the resistors. So I'm going to start slotting those in. And those of you who have watched me work before know I can't really see very well. So I'm just following in the book to see where the resistors go. Now, this video is not intended to replace the written documentation at all. It's really just supposed to demonstrate the process and some of the techniques. I'm not going to talk in this video about how to bend resistor leads. I will mention that a couple things. Verify values every time. You know, it's kind of like that adage, measure twice, cut once. Well, it's the same with soldering. If you put the resistor in the wrong spot, you want to know that before you solder it down, because removing components is a pain. So you'll see me verifying these, even though I already know what they are because I've got them laid out. Double checking everything here. to make sure I don't make a mistake. Hello, there it is. And regarding bending resistor leads, I always bend them so that the value marking is legible after. So let's check our focus speed here. Yeah, look at that. So there's 47 k ohms there. This is the JFET bias resistor, so that value will vary based on your kit. 10 meg there. So you want to bend the leads so that you can read the markings later, because if something goes wrong with the build, one of the first things you'll do is verify that you've got the right parts in the right places. And then as far as the techniques for bending resistors, I actually talk about that I think in the very first live stream that I did. It was the T25. I think I demonstrated a couple of different techniques for, that's 8. I'm running out of resistors here. There we go. A couple different techniques. I usually eyeball it. If you've had a lot of practice, that's the fastest way. There's also a 3D printed tool that you can grab that allows you to just sort of bend the leads over a spaced piece of plastic. 56.2, let me just double check that. Yeah. And both those techniques work really well. Almost done here. So one of the benefits of this kit is that the parts count is pretty low. If you're familiar with the T25, this is like a little harder than that. The T25 is an electret circuit, which means that the capsule doesn't need external power. And the nice thing about that is you can cut some parts off of the circuit board, because normally the power supply to the capsule would have some filtering, which means you'd have some resistors and capacitors that are there to basically noise filter the DC power supply to the capsule. And if you have an electric capsule like the T25, then you don't need any of that stuff. So whereas that mic has, I don't know, like 15 components, this one has a few more, but honestly not a lot more. I mean, you can see in terms of parts count, I'm half done, which is pretty nice. Regarding magnifying glasses, super useful. We sell these. You can get them on Amazon as well. A couple of batteries in there for the LED, and it's plastic, and it's about a 5x mag, I think. So yeah, so I dig this a lot. I have actually cases of these. Okay, so always check your placements before soldering. Now I've just done that. So options here. What I'm going to do is just turn the board over, because the board will press itself down against the resistors and hold them in place. If you wanted, you could take some like blue painter's masking tape and cover them. And that's great if you're working with one of those swivelly PCB vices. But for me right now, I'm just going to do that and let that sit down like that. All right, so now I'm going to try to do some soldering. See how this goes. And so this, I think this is the closest. Yeah, the camera might be a little high, but on the other hand, I'm not really teaching soldering right now, so hopefully people can see well enough. So the fan noise is the fume extractor. You can see the smoke going that way. Oops. So part of the process here is trying to come in from an angle where this, which is hot, isn't going to touch anything that I care about. Looks like I missed one. And sometimes it's just not worth it to try to fight through that forest of leads. So what I'll do is clip these off, all the ones that were soldered, and that gives me access to the couple that might be left. So for those of you who have not built a microphone before, you know, I normally recommend the T25 because it's inexpensive, and as I said a minute ago, the parts count is lower. But if you have a 990, this one is not significantly harder. And the MXL 990 is, at least in the US, ubiquitous. I mean, they're everywhere. Okay, so now let's check. Just go back over, look at the solder joints, make sure you didn't miss any. Make sure you don't see any voids or other issues like that. I skipped a step. The book recommends putting the diode in first, and that would have been good. It doesn't really matter, so I'll just do that step now. There we go. Okay. It's always good to tin the iron. Now, I didn't mention it, but I did do it right. Whenever you solder a diode, a red flag should go off, a little alarm bell in your head, because diodes are polarized. Resistors are not. Resistors can go in either orientation. Diodes, though, the black stripe on the diode body has to line up with the white stripe on the circuit board. You can maybe see it more easily. In the photo here, you can see the white stripe in the silk screen underneath the diode, and then the black stripe lays on top of it, meaning at that end of the diode. Because they're polarized and they won't work properly if you put them in the other direction. Okay, so far so good. Next step is a couple of ceramic capacitors. 2C7. Okay, so we got to find that's C6, that's C7. So that's one. And then this one, 6 and 10. There's one. So the arrangement of parts, the order of parts installation is kind of by height. And that is, again, a sort of build time optimization. And that is, part of the reason I put the diode in first in the book. Again, I didn't do it in this demonstration, but the diode sits a little shorter, as you can see right in there. And that way you can do this trick of just laying the thing upside down, laying the circuit board upside down while you're soldering. But the other thing I'm going to demonstrate is with components like this to solder one leg at a time to check height. So I'll show you what that means. Okay, so I just soldered one leg of each of those 3 parts. And that way I can come back and say, yep, that one looks good. That one looks good. Standing up a little bit that way, but I can live with it. And this one here, right there, also looks good. Sometimes you'll see a part that, is raised on one leg, and what you would do is press down on the thing that you're moving and then reheat the soldered leg to reseat it. And then you move the heat away after the capacitor or component has moved down, and then you can go back and resolder the other leg. I don't need to do that here because everything worked well enough. So I saw somebody mentioned in the chat fume extractors. So yeah, I've got if you're able to see this, yeah, right here. This is the intake for a big Hacko, like floor standing. It's like a canister vacuum kind of thing. They work pretty well. They're expensive. You can buy a fume extractor for less. Those are basically like a muffin fan with a piece of charcoal that sits in the front of it. And they work to some degree. They don't suck very hard, so you kind of have to position them, like right on top of your work. And elevated is good too. And I don't understand why those things always have these little, like 2-inch tall stands on them. So the thing is sitting down on the bench and all the smoke is 8 inches in the air right over the top of it. So getting some height is good because smoke rises, as it turns out. So yeah, fume extractor, good because solder is not good for you. You don't want to breathe a lot of that stuff. I like leaded solder because it flows better, but lead fumes are a little toxic. So now we're on to the JFET. So we bias these here in the shop. What that means is that we find the optimal operating point for each individual component within this circuit. So we have a whole test jig to do that. And the value that you need is written on the piece of paper, and the resistor that you need is in there as well. And I've already installed it. If you buy 2 of these kits, and this is true of any of the transformer coupled kits that we make, if you buy 2 kits, these will probably be different across the 2 kits. So what you don't want to do is dump them all out in a big pile, because then you can't tell which resistor that JFET goes with. So keep these parts together until you're ready to install them. Now, one thing I always like to do, because these are old, is take a little alcohol and scrub these pins a little bit. And then we're going to bend the gate pin, which is the, in a sense, it's the audio input pin. Did I really manage to leave all of my pliers the other end of the building? I had a kind of a wager with myself. Would I remember all the tools that I need? Because I don't usually work here. And the answer is no, I won't remember. So give me 30 seconds. Okay, so now we're going to bend this, and the manual shows how to do this. You basically want to grab that third leg, counting left to right from the face, the flat face that you can read, and just bend it 90 degrees to the right. And again, there's a photo in the manual that shows the result. Okay. The reason is that that's a very high impedance. Within the mic, that's a high impedance connection, and we don't want to solder it to the circuit board. Soldering high impedance connections to the circuit board is a shortcut that some manufacturers will take to save money, but it can introduce audio problems. And so we form those joints in the air. I'm just going to spread these a tiny amount so we can install this at T1. Now this is polarized as well. You can see on the circuit board there's a corresponding shape. So this has one flat face right there. And so we install it so that the shape of the transistor body matches. Come on. Okay. Now the other thing we need to watch out for, one, that it doesn't stand up too tall. Okay, so you don't want to solder this thing way up like that because it won't fit in the microphone. So we want to get it down, but we also want this bent lead to not have its bend touch the surface, right? So you don't want to you do not want to cram this in so far that this leg is touching the circuit board after all. Okay, so now we tin our soldering iron. Oops, sorry. Okay, so Jacob asks, talk about FET biasing. Why is it important? Why is it impractical for DIY? And Brian asks about ESD. Yeah, so that's an easier question. So it is best if you don't have a big static charge while you're touching these components, because they can be sensitive. In practice, it's pretty unusual to zap a JFET, but it has happened. So if you have a carpeted workspace, maybe touch a light switch or something. You know, I used to work in years and years ago, I volunteered at a hospital, and there was this is a kind of a weird story, but I'm going to take a quick moment for this. There was in the hospital, there was next to the bank of elevator buttons, there was like a bare patch on the wall, in the wallpaper or paint or whatever. A bare patch, meaning like a rubbed spot. And as I was volunteering there, I was a kid, I was volunteering, I was like delivering x-rays or whatever. And I'd be paired with some more senior employee, and they would, as they approached the elevator, they would always brush their knuckles against the wall next to the elevator button before they pressed the button to go up or down, to call the elevator car. And I asked why, and they said, because otherwise you get zapped, because they're walking around, maybe even pushing a gurney that has rubber wheels across a carpeted hallway. And then they go to touch the elevator button and they'd get this big static shock every time. So they would kind of ground themselves, short themselves by kind of rubbing their knuckles against the wall. So yeah, if you have a carpeted workspace, it is good to touch something that is grounded. A lot of the time, the housing of electrical appliances is grounded. So you don't zap your components. That's a good thing. This is not an ESD mat. We have some on the benches. I don't know if they really help. We haven't really had too many problems with stuff getting zapped. Now about JFET biasing, it's important because if you don't, your mic will distort, maybe a lot. And why is it impractical for DIY? Because because of all the stuff you need. You need a test jig, which is a circuit that lets you do this measurement. You need a signal injector. You need a power supply. You need an oscilloscope or audio software that'll do like a Fourier transform. So it's quite involved to get all that stuff going, and it just takes a lot of kind of moving pieces. Okay, so I don't want to take too much time. Let me get back into the build, because I'm no way in hell am I going to finish it today. Well, let's see. Okay, so that's the JFET now. 1 gig resistor. Actually, that's a good question for those of you who are sticking around. I don't know, maybe it is more valuable that I talk more and not worry about how long it takes. Let me know what you think about that. So here's the 1 gig resistor. So for now, we're going to do something a little different. Just as a placeholder, we're going to round this off, just like this. And then we're going to, so this is R2. So we're going to drop this in here, and we're going to put the bent lead into this hole. And it won't stay there, but this just kind of keeps it out of the way for now. Okay, and caveat says before, you don't want this to be standing way up there because it won't fit in the microphone, and you don't want this to touch anything, because that's one of those dead bug style connections that are made in the air because they're really sensitive. And the way this board sits in the mic, in most cases, that bent lead is pointing up towards the deck of the microphone. So if it stands too tall, it's going to be shorting against this, which would be really bad. Okay. So clip this guy and clip this guy too. Just soldered the one, but okay. Now a little feedback capacitor. So we include this little ceramic feedback capacitor. I'm sorry, that was off camera. So we're going to just straighten out one lead so it points sideways. And this goes at C2, which is here. And all of these things, you know, I'm actually going to rebend that. Yeah, instead of having that point up, I have it point down. Yeah, I like that better. So this is similar to the JFET in the sense that we want to have one lead formed in the air, but we don't want that bent lead to touch the surface of the circuit board, because that would be an opportunity for current to leak. Okay, so that's in there. Now we're just going to cover him up in tape so he doesn't fall when we turn this over. But we can adjust it if we need to. Okay, next up is the output cap. This is a very special European film capacitor. Not polarized, but I am checking height to make sure that this is sitting on the board. This one has pretty thick leads, so I'm covering the trajectory sort of direction with my fingertips so this thing doesn't course, this one sticks. Often those shoot across the room. You have to be careful. Sorry, I'm just reading some chat here. In this circuit, there is no high-frequency correction. We do offer a K67-ish capsule as an option with this circuit, but if you read the product page or the email that I sent to the mailing list, this capsule that we're calling RK67C is unlike any other K67 in that it doesn't need high-frequency correction. So the feedback cap here is not doing high-frequency roll-off. It is doing broadband feedback. So next up are the electrolytics. Like diodes, anytime you hear electrolytic capacitor, you should get an alarm bell in your head that says you have to put this in the right way. So there's the negative lead, shorter lead is negative, and then confirm by looking at the Sook screen. And I've got these all arranged so that the negative lead is on this side of the board. So all three of these go in the same way. Having some trouble today. So there are some questions about the capsules. So you can see those are all aligned. I'm going to do the same trick with these of soldering one lead at a time. So these are the tallest thing on the board, and you can see this one slipped a little bit. See that gap below this component? So I'm going to fix that. The clearance, the vertical clearance in this particular installation is fairly tight. So we can't afford to have things standing up. So we'll just reheat that while I'm pressing down from underneath. And then I can come back and solder the remaining leads. So questions about capsule voicing. You know, I'm always looking for sonic diversity. That's a phrase I use to describe the idea that a good mic collection has a lot of different sounds in it. Because if all of your mics sound the same, then you're going to have some tough sessions, because if one of your mics doesn't work on a particular source for whatever reason, if you have nothing that sounds different, I mean, what are you supposed to do? So, so I think sonic diversity is an important thing, and it's kind of a guiding principle for me in designing microphones. And so next up is cleaning the board. Yeah, so this is going to make a mess, but you can't really skip this step because then the board's just a goopy mess and it can attract dust and stuff. Normally I wear rubber gloves, but often forget to pack them for this kind of thing. So paper towel dipped in 99% alcohol, and then you just scrub. So anyway, capsule voicing. So yeah, you know, I went back and forth on what to call those capsules, because calling the RK47C that suggests that it's simply a cardioid version of the RK47, and it's not. It's a little bit more, it's a little darker, which is actually a really popular sound. And And then the 67 is basically flat. 67 is pretty flat, with just the merest little bump in the top, like around 10K. And now, the thing to keep in mind, though, is that the sound of a capsule depends on the sound, depends on the acoustic environment in which it is installed. So in a 50 millimeter microphone, it's going to sound one way. And in a 60 millimeter microphone like this one, it's going to sound a little different. And if the grill looks like this, it might be a little different than if it looks like the tapered grills that we sell. So the testing that we've done has been with the tapered grill. And within this mic body and within that tapered grill, the sound of these capsules changes a little bit because basically the acoustic environment pushes down on the mid-range a little bit. Making a little more noise here. So that's the board. So even with all my yammering, that was like 45 minutes. So pretty quick if you have a little bit of experience. Now, the one thing I wanted to check is whether this fits the 990s that have the shorter clearance. On the product page, it mentions compatibility. So this is one of the 990s that has these kind of 9.7 millimeter standoffs as opposed to the 13 millimeters that we took apart 40 minutes ago. So I know this is not going to fit this way. You can see for the board to go into this groove in the side, the capacitors don't clear the body. So my question, though, is will it fit this other way? And it looks like it will if the transformer will clear. So we'll do that next. We'll throw that transformer in real quick. Now I'm going to jump back into the directions. So this actually has me do the input joint first. So this is a terminal. The use of this is optional. This gives you a mechanical support for building this high impedance joint off the surface of the board. So now what I have to do is move this 1 gig lead out of the way because we threw this into the hole where that terminal is supposed to go. And the reason I say the use of this is optional is because at this step right here where you're kind of moving everything out of the way to make room for this is a little tedious. Wrestling this pin in there can be tedious. There we go. So that's in, but not fully seated. It's not critical that you fully seat it. And the best way to do it is to sort of wiggle it back and forth, or you can grab the bottom part and pull. You don't want to apply too much pressure. Obviously, circuit boards are not so strong that you can't break them. Now, all of these flying leads here need to go onto the top part of this terminal pin. Okay, so there's JFET, and they do not need to wrap around. They just need to make contact. So there's the JFET lead. It's touching the terminal, but then I trimmed off the rest. Now this one coming out here is our little feedback cap. So we'll bend that around a little bit. Clip off the excess. And the last one is the 1 gig resistor, which I'm going to try to form a little bit here. So put a little bend in it there. Maybe I bring it around the outside. So I'm just doing a little bit of a 3D jigsaw puzzle here. There. So now all of those things are making contact. You can get that in there. There you go. You can see them all in there. So that's prepped. You can cut this off. I'm not going to at the moment because these are new and I don't want to put a divot in them. And that's a pretty heavy pin. Next up is circuit board inspection, which I've kind of been doing along the way. Next up, we throw the transformer in. So we put the wires this way. So the way this works is it just sits in there. So there's a cutout for the bobbins. This sits in there like this. We include a couple of zip ties. So teeth towards this, towards the middle, that way. Am I doing something wrong here? Yes. I said it right, but I put it in wrong. There's the teeth. How much does the transformer affect the sound? Coloring the sound. So that's a good question. And the answer is it depends. In this particular mic, not a lot. There are cases where the transformer, a lot of cases, where the transformer doesn't pass a full frequency response. A lot of transformers are rolled off at the top or rolled off at the bottom. It's almost as if it's, and I'm not a transformer designer, so what I'm about to say is my impression and certainly not a statement of, universal truth. It seems to me, based on my experience, that it's almost like it's really difficult to get 20 to 20 out of a transformer, and that sometimes designers have to shift it, towards the lows or towards the highs. The other thing about transformers is core size. Small core transformers, and this would be a small core. I mean, I've seen smaller. Look inside an AT2020. But small core transformers can saturate, especially in the lows. But that also depends on the materials. There are certain kinds of lamination that are, well, they just behave differently. Nickels versus irons versus whatever else. And, talk to your favorite transformer company for more on that. Anyway, in this mic, it's not a lot. What we do when we're picking a transformer is we're looking for frequency response, we're looking for saturation characteristics within this circuit. And I've seen good transformers that just don't work with some circuits because there's other factors at play that that are just, certainly more complex than this session warrants attempting to cover. Okay, transformer mounted. Back to our upside down 990 just to see. So the flat edges go in the sides, the cutouts. Yeah, look at that. So it looks like it would be compatible. Now, we're not going to stall on that one because we already put a capsule in the other one. So theoretically, I've only got 5 minutes left, but I think I'm just going to try to finish this. And that way it's all in one video. So we already did the installation of the capsule. So now we'd have to do XLR wiring and capsule wiring. So we're 5 solder joints away from a voltage test. Now, to be fair, those are the 5 hardest joints in the entire microphone. First thing we are going to do is prep these XLR wires. So we cut them off before, and I mentioned wanting to get some clean copper out of them. So having a wire stripper is super useful. So you throw this in there. Not sure how heavy that wire is, but maybe something like this. Yeah, and these inexpensive mics, this copper can be pretty funky sometimes. If you have access to good wire, you might consider swapping out these XLR wires. I mean, it is sort of the last stop that your audio makes on its way out into the world. Sorry. Is that working? There we go. So you don't need a wire stripper for that. But it makes it easier. Now, you could tin these. In the interests of haste, I won't. Also, if you tin them, you have to be careful because the solder pad holes are not very big. And so if you put too much solder on these, they won't fit. And then you're just adding time. So I think the book recommends having the input joint up at the front of the mic. It doesn't really matter. And that relates to if the board goes in this way or this way. But I do think it suggests doing it that way. So now what we're going to do is find XLR 2 and 1 and 3. So 2 is there. Always, always, always trace your XLR wires visually. Don't assume that, 1 is black, 2 is red. Because once in a while you'll be wrong and then you'll be wondering why the mic doesn't work. In this case, 1 is black, 2 is red. I mean, that's kind of MXL standard. Yeah, 1 is black, 2 is red. Okay, so we need 2. Thanks, Bill. Dinner can wait. Talk about technical details like transformers, different circuits that are too complex to build live stream. Well, honestly, I'm hoping to build almost everything live stream. We'll see how it goes. These take kind of a lot of prep. I don't usually have a whole DIY rig here. I do have where I'm sitting right now is my new video kind of broadcast rig, but I had to move in the fume extractor and the soldering iron and tools, and apparently lost my needle nose along the way. So here's XLR2. Oh, so I almost did something not very bright, and that is solder with an exposed capsule, so don't do that. If you have anything to cover it with, you might save yourself the pain of dropping solder or flux through your brand new capsule's diaphragm. So I left the heat on longer than I normally would because that wire looked kind of cruddy, and I'm thinking maybe I can burn off some of those, I don't know, impurities or corrosion or something. XLR1, so 1 was black. And on this board, we've been trying to do this on all the products, although it could be that not all have been updated yet, but put the silk screening for wire joints on the bottom, which just makes it easier than trying to mentally turn things over in your head and memorize where they are. So there's XLR1. When you insert these, it's good to inspect them to make sure that they're not frayed. Sometimes you'll stick a wire in and one strand will peel off and kind of go sideways. And the risk is that if things are tight, which they are relatively so in this layout, it could short against something else. Short circuits are usually bad. So let me just check this. Yeah, looking good. And you also, in general, want to have the insulation basically go down and be touching the surface of the circuit board. You don't want a lot of exposed bare wire underneath the board, like between where the insulation stops and where the wire goes into the circuit board. It's going to be a little awkward. Two down. one more XLR to go. So that is XLR 3. And by happy circumstance, that's the one pad that I have left. If you are overzealous in stripping the insulation off, you might find that your leads, the conductors, individual strands of wire got clipped, in which case you can, clip a little more to get good, fresh wire. Sometimes it's good, too, to just snip off the sort of split ends. There we go. Wiring is harder than soldering components. When you put a resistor in place, it tends to just sit there. Wires don't. So is it totally obvious to everyone that I've got a foot switch for the fume extractor? It's actually pretty awesome. So I'm clipping off the ends of the XLR wires. I do see some customer builds where that wasn't done, and it always makes me cringe a little bit. Normally, I would use a Q-tip and alcohol and clean those joints. But in this case, I'm going to skip it. Okay, so there's front of mic, here's front of... Okay, but now what we need to do is transformer wires. Okay, red TP1, gray TP2. So let's talk about wire length. Shortened to 2.5 inches. So you could leave the wires long. It just makes them hard to cram back into the microphone later. I tend to leave them a little longer than I should, only because I like to have my options open if later I'm going to take this apart for some reason. I think for most people it's not going to happen. So cut those off. And then we'll do a quick trim. Do red and gray. So red and gray are the primaries. They are the inputs, transformer inputs. And the board is marked TRP, sorry, not TRP, TP1, transformer primary 1, and then TP2. So TP1 is red. Now, the way we've done this is all the wires are on top of the board, so that's how we're going to route them. You wouldn't be able to reach them around. And also for reference, we installed the capsule first. And I usually don't do that. I usually do that last. I wanted to do it first so that anyone joining late, because we had to move this stream, I wanted to make sure they had a minute to find it without missing the actual circuit build, which I think is the reason most people wanted to tune in. But the problem with installing capsule first is now it's along for the ride while we do all this soldering. One thing you can do is throw a grill on there with a short M2 metric screw. Or maybe even the screw that comes with the mic. You'll have to put it in. I mean, it's a really long screw. But it would probably work. So same drill here. Insert the wire until the insulation touches the surface of the board. And then try to arrange things so they're not going to move. I do tend to solder one wire at a time because they tend not to stay put. Michael asks, which body is this in which the PCB sits right side up? So this kit only fits one microphone, and that is the MXL 990. And the reason I went to the trouble of making a kit for the 990 is, well, there's a couple. One is that we already had a transformerless 990 kit, so I already had the board outline and dimensions. So making this was relatively easy. Two, I wanted to make a low-cost transformer kit that didn't really give up anything in terms of sound quality. And that wire is not quite all the way down, but it's going to be okay. And but there's two different 990s, maybe more than two. TS1 is yellow. So most 990s, the components are on top of the board, and more to the point, the amount of space between the board and this plate is what is it, 13 millimeters, something like that. It's in the book and it's on the website. TS1 yellow. But in some cases, they came from the factory, kind of upside down with less space. And I was just testing that. This is interesting. So here's one of those cases where, I don't know if this will work, where a wire literally did fray out, and see that? It doesn't quite reach that capacitor, but you don't want that. Anyway, I hadn't had an opportunity to test whether this circuit board would fit that particular production run of 990 microphones that have the circuit board upside down, or again, more to the point, that allow much less vertical clearance between the top of the circuit board and the bottom of the capsule deck. Okay, getting there. So it's always kind of interesting to me that stuffing the circuit board, which seems like it ought to be most of the job, is really only, I don't know, 30, 40, 50% maybe. Because I think we'll probably have spent more time wiring, even though there's only 9 wire joints. We'll probably have spent maybe as much time wiring as we did stuffing all those components. Okay, TS2. There we go. Oh, here we go. This is what I should have been doing. It's not my favorite grill from an aesthetic or sonic perspective, but it makes a wonderful stand for the mic. Okay, so I will clean those solder joints later. Sometimes people ask if they should twist these wires together, and the answer is it doesn't matter. Okay, capsule wires. And then plug it in. Okay, so the easy one is the front diaphragm wire, which we know is white. And there is an FD pad on the circuit board. So let's pull these wires out. Okay, so right there, FD. And this, that wire is good to go. So we just drop this white wire in from the top of the board. The last wire is the backplate wire, and in this microphone, that's where we're getting the audio signal. This is the hardest joint in the entire mic, because you've got a bunch of different things coming together. And it all has to happen in space, in the air. Earlier I mentioned dead bug style. What that means is these are not soldered to the circuit board. Interesting. And so when integrated circuits are, when engineers need to connect those to a circuit in a way that they're not sitting on the circuit board, they would do them upside down with all the little pins sticking up in the air. So that became known as dead bug style. And so it's just kind of a shorthand name for this process that I'm doing. So now, and the reason this is hard is because the circuit board doesn't want to stay put. And the wire has a mind of its own. So if you're lucky, thought I was going to be lucky. If you're lucky, there's enough of a sort of jungle gym of components in here that you can get the wire to be sort of wedged or caught in there. So once you've got it, so you've got bare wire in the joint, tape it down so that it can't spring away, because what will happen is if there's any spring tension there, once you touch your soldering iron to it, the wire can release, and then you have to start over. And sometimes it's even worse than that, because you actually solder the joint with no wire in it. So then you have to remove solder, and then you risk heat damage and all that kind of stuff. It's good to have the tip clean. Wire moved after all. Let me back it out a little bit. Like I said, this is the hardest joint, but your patience will be rewarded. You know, one of the things that's making this a little harder I think I can get away with that, is that the tip of that wire was tinned. Oh, did it move? Yeah, we'll see if that worked. The wire moved again. I think we're good. Yeah. If the tip of the wire is not tinned, it can be easier to wedge it in there. It was a little stiff. Okay, now what we're going to do is just this last little bit of assembly. You can't test the mic without a grill on, so we'll throw a grill on. I'll also mention that in the manual, there are some voltage test points. And if the mic works, then you don't really need them. In general, I would advise against probing your microphone with conductive things, meaning like multimeter probes, unless you have a problem that you're trying to fix. So if the mic works, then ignore the voltage test documentation. But if you do need to test voltages, one of the main voltages that you would test would be the JFET source and drain, which are the two leads of the JFET that are soldered directly to the circuit board, not the one that's bent sideways. And wow, getting to the point where I need to see the eye doctor. If you do need to measure source and drain voltages, those pads are marked on the bottom silkscreen, which makes it easier. So you don't have to go hunting for them. As you can see, reassembling these kind of all-in-one designs where one screw does everything, you know, circuit board and grill, can be challenging. Okay, one down. Let's grab the other one. I grabbed this grill out of the junk pile, so there we go. Okay, so that's the mic. Now, this is a problem, right? You don't want these wires to be in the way when you reassemble, because they will be sheared off and not work. So there's better ways to route these. Yeah, so I would, if I was actually building this mic for me, I would probably take that circuit board back out and stuff those in a better way. But let's do a quick test. All right, so there's no body on it, so it might hum. Let's do this. So that's the mic, and but you're not hearing it yet. Let me shield it sort of with my hands, and maybe what I should do is this. Seriously? Okay. Whoa. Yeah, that is humming. That's tolerable. Yeah. So now Now you're, yeah, okay. So I have a routing problem in my mixer here. I'm getting audio through the mic, but it's, I didn't set this up for the demo. So not a problem with the mic, a problem with my mixer that I'm not going to try to fix right now. What I will do is remind everyone that the giveaway, if you leave a comment, in the video, which I think you can't do until after the session, then you'd be entered into a drawing to win one of these kits, and not just the circuit kit, but also the capsule. So you can pick which capsule, either that the new 47 or the new 87 capsule, and then let's see if there's any other questions. What is the polarity of the blue capsule wire? You don't need to worry about polarity in this kit because the manual tells you exactly which way to install it. So the blue wire is the backplate wire, and we're pulling audio signal from it, and we're sending polarizing voltage to the diaphragm, which is how we get away with not having a coupling cap. Yeah, that's it. So that's everything I wanted to show. So thanks to everyone for sticking around, and enjoy your holiday weekend. And if you have any questions about this or other kits, please let me know. And that's it. Thank you.